Okay, Rita and Jonathan, hope you guys are doing well, and I apologize for taking quite a long time to get to this video, but hopefully this will help you, and hopefully you'll understand what to do when I'm done showing you these two problems, page 169 and 11 and 12. Okay, so here we go. Alright, number 11. Alright, here's the answer right here. Obviously, we're not going to worry about that right now. Now, whenever you're solving a three variable system, the first thing you want to do, Jonathan, is get rid of or eliminate your x's, your y's, or your z's. Okay? Totally your decision. Now think about it. The y's would be the most difficult to get rid of because you've got 2's, 3's, and 5's. Okay? The z's, they're kind of easy because you have a 1 right here. Okay? And here's why that would be easy. If I multiplied this middle equation here by a 6, that would give me a 6 here. It'd give me an 18 here because 6 times 3 is 18. And 6 times 1 is 6. And that would cancel these out very nicely. And then I could multiply this middle equation by 4. And that would give me a 4 here, which would cancel with this. So that's pretty easy. But the easiest variable I see are the x's. Because you've got a 1 here, a 1 here, and a 2 here. So I'm going to eliminate my x's. Now, Jonathan, you have to do that 2 times. Okay? You have to eliminate your x's 2 different times. So the first thing I'm going to do is I'm going to take my first two equations here, and I'm going to multiply one of them by a negative 1. I'm going to multiply by a negative 1 to give me a negative 1 right here. Remember, when there's no variable here, there's really a 1 here and a 1 here. Okay? So, I said variable, sorry. If there's no coefficient here, then your coefficient is 1 and 1. Alright, here we go. Now, you can multiply the top or the bottom by a negative number. I'm going to multiply the top by a negative 1. Alright? So negative 1 times x is negative x. Negative 1 times 2 is negative 2. Negative 1 times negative 6 is a positive 6. Alright? Negative 1 times 23, negative 23. Now the second equation, right here, this one, I leave that alone, okay? So I have x plus 3y plus z equals 4. Add these two together, these cancel. Negative 2 plus 3 is a positive 1. You're welcome to put the 1, but you don't have to if you don't want to. 6 plus 1 is 7. And negative 23 and 4 is negative 19. So, there's one equation right there, okay? I'm going to grab that and pull it and put it down here, alright? So, I eliminated my x's one time. Now you got to do it again. Don't forget, you got to do it twice. Do not use the same two equations. You can use 1 and 3 or 2 and 3. It does not matter, Jonathan. For me, I'm going to use these two equations here. The bottom two. Now, I have a 1 right here. I really wish I had a negative 2 right here. So if I multiply this middle equation here by a negative 2, let's see what I get. Negative 2 times x, negative 2x, negative 2 times 3, negative 6, negative 2 times 1, negative 2, and negative 2 times 4, negative 8. Now your bottom equation stays the same. And there we go. Okay, let's add these two together. These cancel. Negative 6, positive 5. That's a negative 1y. Negative 2, negative 4. That's negative 6. Negative 8 and 24. That's a positive 16. Alright, so we're going to take this equation and move it down here. Now, look what I have, Jonathan. Thankfully I have two equations with a y and a z. Okay, so now I can work with these two equations. And thankfully, there's not a lot of work to do. Look at my y's, Jonathan. They're already ready to eliminate. I have a positive 1 here and a negative 1 here. Now, let's pretend for a second that didn't happen, okay? Let's pretend that we have a 7 right here. Well, if that's the case, I would then multiply this bottom equation by 7, which would give me a negative 7 here, and then negative 42 here, so on and so forth. And I could cancel out my y's that way, okay? But I don't have to do that because I have a negative y and a positive y. So I can add these together right now. Those cancel. I'm left with 1z equals negative 3. Well, 1z is z. Z equals negative 3. Check. Now, you're going to pick up your negative 3 and put it in for z here or here. Jonathan, it doesn't matter which equation you choose, okay? I'm going to choose the top one because I feel like it. So y plus 7z equals negative 19. Where the z is, I'm going to substitute negative 3. 7 times negative 3 is a negative 21. Bring the negative 21 over, make it a positive 21, and y equals 2. Check. Now, I know what z equals, I know what y equals. I'm going to pick up those two values, and I'm going to substitute them in for y and z, either here or here or here. It doesn't matter, Jonathan, okay? I'm going to use this equation here only because I have room underneath it to do my work, okay? It really doesn't matter which equation you choose. So 2x, and then a positive 5, and then parentheses for y, I'm going to substitute 2. And then negative 4, and then for z, I'm going to substitute negative 3. And here we go. 5 times 2 is 10. Negative 4 times negative 3 is positive 12. Combine these two numbers. Positive 10, positive 12, positive 22. Now to solve for x, bring the 22 over, make it a negative 22. And we're left with 2x equals 2. Negative 24 and a positive 22. Or positive 24 and negative 22. Leaves you with positive 2. Divide both sides by 2, and x equals 1. Check. So there's your answer. 1 comma 2 comma negative 3. Okay? Go back and watch that again if you need to, Jonathan, but that's how you solve these, okay? Let's try another one. Now, when I look at this one here, just like the last problem, I have to eliminate one of my variables. How many times? 2 times, okay? Now, sometimes you'll get lucky, Jonathan, and you'll go to eliminate one of your variables, and you'll accidentally eliminate 2, and that's good when that happens, but most of the time, you're going to have to eliminate one of your variables 2 different times. So let's pick out the easiest one. The hardest one, z. You've got a 7, a 3, and an 18. That's a circus, okay? This one's okay, but you've got a 1, a 3, and a 4. I like this one. You've got a 1, a 2, a 1 and a 2, and a 6. So personally, I'm going to eliminate my y's. Now, this you could do the x's, that's fine, but I like how the 2 and the 6 can be worked, like multiply the 2 by a 3, which would give you a 6. I just like this a lot better, okay? So I'm going to eliminate my y's. Now, I'm going to use this equation, Jonathan, and this equation, okay, first. Now, I have a positive 2 here. I have a negative 1 here. I really wish I had a negative 2 right here. That would cancel out my y's very nicely. Positive 2, negative 2. So I'm going to multiply this bottom equation by a negative 2. No, I'm sorry, a positive 2. And let's see what happens. 2 times 3 is 6. 2 times negative 1 is a negative 2. 2 times negative 3 is a negative 6. And 2 times negative 7 is a negative 14. Now, bring over your top equation. Negative x, positive 2y, negative 7z equals negative 17. Let's add these two together. Negative 1, positive 6, that's 5x. These cancel. Negative 7, negative 6, negative 13. Negative 17, negative 14, negative 31. So there's one equation that has no y. The y is gone, okay? Now don't forget, Jonathan, we use the first and the third, or the top and the bottom equation, so denominator y's, I can use my first two or my bottom two. I think I'm going to go with, I'm going to use my top two. Okay? Now, if I multiply this top equation by 3, that would give me a 6 right here. And that doesn't help, Jonathan, because a positive 6 and a positive 6 don't cancel. So I'm going to have to multiply by a negative 3. That would give me a negative 6 right here. So negative 3 times negative 1 gives me a positive 3. Negative 3 times a positive 2 is a negative 6. A negative 3 times a negative 7 is a positive 21. And a negative 3 times a negative 17 is a positive 51. Okay, now bring over your middle equation or your second equation, and we're going to leave that alone. And let's see what we come up with, okay? Here we go. 7x. These cancel. 39. 71. So my y's canceled out again. So now I have another equation that does not have a y in it, okay? So that's pretty good, Jonathan. Now I'm doing pretty good, okay? So, now we've got to do a little work on this equation. Let's see what we can come up with. Now, Jonathan, obviously I want to eliminate my x's or my z's. Now look, you can make both of these become 35, multiply the top by 5, and the bottom by 7. Now, that would give you a positive 35 and a positive 35. You want one of them to be negative, so you could make this negative here. Or you could make this negative here. It doesn't matter. I'm going to do something different though, Jonathan. Now you can do that, okay? Feel free to do that, no problem, okay? You'll get the same answer. I'm going to do this. I noticed that 13 times 3 is 39. So if I multiply this bottom equation by 3, that'll give me a negative 39 right here, which will cancel this z term right here. So let's see what happens. 3 times 5 is 15. 3 times negative 13, negative 39. 3 times negative 31 is a negative 93. Now, up here I have 7x, positive 39z, and 71. Let's add these together. 7 and 15, 22x. These cancel. This would be a negative 22. Negative 22. Divide both sides by 22. And that x equals negative 1. Check. Now that I know that x equals negative 1, I can pick up negative 1 and I can put it here, or here, or here, or here. It doesn't matter, okay? Now I'm going to choose to use this equation right here because I have room underneath it to work. So 5, negative 1 for x, negative 13z equals negative 31. 5 times negative 1 is a negative 5. Wow, Jonathan, I'm really struggling, aren't I? Alright, let's try this again. 5 times negative 1 is negative 5. Bring down your negative 13z. Bring down your equal sign. Bring down your negative 31. Now, if we're going to get z by itself, we must bring this negative 5 over and make it a positive 5. So now we're left with negative 13z equals negative 26. Okay? Divide both sides by negative 13. Negative divided by a negative is positive. 26 divided by 13 is 2. So z equals 2. And that checks. Z equals 2. So now, to finish the problem up, Jonathan, all that I have to do is substitute this value in for x and this value in for z. You can use this equation, or this one, or this one. It really doesn't matter, okay? So I'm going to take the bottom one because I've got room to work with here. And here we go. Where the x is, I'm going to substitute a negative 1. Where the y is, I'll leave that negative y. Where the z is, I'm going to substitute 2. We're going to solve for y. 3 times negative 1, negative 3. Bring down your negative y. Negative 3 times 2, negative 6. Combine your like terms. I have negative y, negative 3, negative 6. You owe me 3. You owe me 6 more. So you owe me $9. Now bring the negative 9 over and make it a positive 9. So negative y equals 2. Now, there's really a negative 1 here, even though you can't see it. So if you divide both sides by negative 1, 2 divided by negative 1 is negative 2, which checks. So there's your answer. X, Y, Z. Okay? Jonathan, I hope this has been a help to you. I hope I haven't gone too fast.